Hello, and welcome to the first episode in my Let's Make an Engine series. In this series, I'm going to walk you through making a 2D game engine using C++, and we're going to be using SDL as our backend. I'll show you what I've got working so far and where this series is going to take us real quick with the project that I'm currently working on. So this is my engine right now. It's called Hippo Editor. This is the editor for my engine. You can see I've got a projects directory and a couple of projects here that I've got to choose from. You can also create a new one or modify some preferences. So to walk you through what we're going to try to aim towards, I'll just go through some of these projects here to show what the engine can do. So I'll start off by loading this blueprint tests project. So the first thing you see is we've got a sort of docked panels on the side. This is all using IMGUI with obviously this big node panel in the middle, and this node panel is an IMGUI extension that allows us to generate nodes and have them do logic. At the bottom I've got a printout terminal style panel, and we've got a couple more on the sides. So the first thing I'll show you here is I'll just look at the editor view, and you can see I've got three. They're called balls. They're not really balls, they're just rects because I don't do any balls yet here, but I have a main camera, and if you look at the game view, this is what the main camera is, and this camera is actually the camera that the user will see in the game. And I can see modify the camera position, and everything works accordingly. And I'll just go ahead and press play here, so I'll start the runtime. And what you're looking at is just some simple animation on these three objects here. And this is all driven by the blueprints panel. So you can see we've got a timer that goes through some sine waves, sine and cos, multiplied a little bit to modify things like speed and radius, or in the other case, just sort of amplitude. And you can see we're setting the transform component of ball 1, ball 2, and ball 3 here. And in fact, if I just dock this to the bottom, you can see that while the runtime is actually running, I can modify these values. So this would be the speed here. So if I increase it, you see it speeds up. And also increase this value to increase the amplitude of the sine and cos waves here. And this is all happening at runtime. If I stop the runtime, everything will reset back to the way it was before I started making modifications live. So that's a quick rundown of sort of the blueprint panel and what it can do. If I quit this, actually I think I have another scene here. Yeah, I actually have another scene here, so clouds. So I have a file browser here. I can open up the clouds scene, and you can see I've now loaded up clouds. It's not updating up top. And this is just, again, another sort of simple introduction into what we can do here. So now I've got a cloud holder object that has three children. It's those three from before. And again, a main camera. And if I go ahead and press start runtime, you'll see what the cloud sort of blueprint is doing. It's sort of bobbing on the Y with the sine wave, and it's moving continuously to the left until we hit a certain point, and then we sort of reset the position. So again, by making modifications live, we can sort of make this look a little nicer. Maybe I'll make this a little larger here. So again, modifying speed, same as we were doing before. And what I'm doing here is this is resetting the position. So you can see I do a comparison on the X position. If it's less than negative 500, I'll go down here and I'll reset the position to 500. So I can actually modify this. Let's make it negative 1500, and so I should go off screen now, and then reset, and then maybe I'll make this 1300. Maybe 1300 is better. And so you can see again, sort of live, I can modify these blueprints and see what the result looks like. I'd be able to save this out as well. These are all serialized on disk. I'm going to go ahead and stop the runtime here. And also show you real quick just the editor panel. Even though it's a 2D engine, I do have the ability to look at the scene in 3D. And you can already see that this is just a 3D. This is the 3D representation of that scene. I've got some layering here on the Z. And the 2D camera is going to view that same scene in orthographic view. I can do the same with the actual game camera. This is a game object with an entity on it. It has a camera entity. And I can do the same thing. I can change the zoom level. I can change the perspective. And then if it's this one, I probably want to pull it back a bit. And there you go. So that's the blueprints test. I'll just close that project and open the physics test because I've got Box2D embedded in here as well. You can see we're not using any blueprints for this one. But here's the scene view of what I've got going, and again, I've got sort of this walls object that holds 4 children. Each children has a mesh, a rigid body, and a box collider with different sort of physics settings. And I've got a ball, again rendered as a square. And if I just press play here on the runtime, you'll see I've actually got a nice box 2D simulation working here. There's going to be a little bit more bounce down here with the restitution on the floor panel here. Restitution is at 0.8. But this is basically the box 2D sort of showcase project. You can see we got simple collisions going, and I can define rigid bodies on any sort of game object or entity that I create. Additionally, we have materials on the side which are not serialized yet, but what I can do is take something like the ball, which is currently a rect textured with an invalid material. So why don't I give it a default green material, and you'll see we see it again, update live. And if I open up the default green material, or I could actually, oops, if we go back to the invalid one, I can actually click this to load it on the material panel here, and I can actually make changes to the values that are going into the shader in real time as well. So this is actually populated automatically from the shader, and so you can see the color is set to green for this one, but I can actually change that live, and again you'll see everything update live. And obviously the floor panel is using the same material here, so that's why it changes along. If I was to open a different material, you can see that I can modify these separately, and you again see those changes live. So that's sort of the end result, so that's where we want to be, and eventually we'll want to take that engine and use it to make something. I have done a similar thing with an earlier iteration of the engine where I've made something and actually published it just to sort of work through the way the engine works and what could be improved. So this is the game that I've published with the earlier iteration of the engine, just to sort of go through the workflow of creating something and actually finishing a project with it. I'll just run it real quick. You can see we've got some fancy animations there, and then a camera, some sort of camera animation there, and you can see it's just a simple endless runner. Art is not made by me, but I've got the author of the art down below. And so you can see I've got some simple commands, some simple animations in 2D sprites here with a parallax background, and that's basically what the game is. It's just an endless runner. You can tell which carrots were drawn by me and which art was drawn by somebody better than me. So to start, I'm going to clone this GitHub repository that I've created for this series, similar to the Let's Make a Game series earlier. And you can see all it's got is a license and a README. So I'll take the copy here, and I use fork. I used to use command line, but I recently found out about fork, which is a really nice way of handling Git projects locally. So you can see I've got, this is the earlier iteration of the engine, my Hippo engine, and now I'll create a clone of this. I guess it copies it, and I will put it here with the name Hippo. I'll go ahead and hit clone, and there we go. We've got that initial commit from the beginning of the month there. And now you can see Hippo folder has been created, and it's got everything I need. I can start working out of this directory, and I can use fork to push my changes up to master or other branches as necessary. The next step here is how we're going to actually generate our projects. And because I'm interested in making this a cross-platform engine, I want to be able to, I don't want to be tied to Visual Studio. And so what that means is I need a solution to make and generate solutions in both Visual Studio, maybe make files for Linux, or Xcode projects maybe for Mac OS. So a couple of years ago I found out about Premake. Back then I believe it was version 4 or 3. Premake is basically a really easy way to sort of generate these projects and deal with dependencies and whatnot. It's basically an alternative to CMake. I can't really speak to the differences in terms of functionality or in-depth, or how in-depth it goes, but it has worked for me, and it's what I currently use for my Hippo engine. So I'm going to go ahead and download this, and I've already got it downloaded. And so what I want to do is have the Premake software here in this folder. It'll be something that's tied to this sort of project and this depot, so it's easy to reference, and I'll be able to generate solutions based on that. So I've downloaded Premake, I've put it in this Premake folder, and I'll just open it up to show you what I've got in here. The license that comes with Premake, so I'll keep that there. and I have the Windows version of Premake 5, I have the Mac OS version of Premake 5, and I have the Linux version of Premake 5. This is just going to be able to ensure that I can run Premake and I can rerun it on any platform that I might be working in. And these are all the exact same versions, they're just different platforms. So now that I've got Premake, I'm going to go back, and the first thing I need to do, and what I like to have for my projects, is a sort of tool set, like a tool pipeline. And this tools pipeline lives outside of Visual Studio, it lives outside of the project itself. It's really just a way for me to type commands that do work for me, so I don't have to keep making changes in Visual Studio or in any other software. So what I'm going to do is open this folder with Visual Studio Code. And so I'm here, and Premake is what I've just added. And I'm actually going to do something else first. I'm going to create my gitignore folder, or sorry, file. This ensures that certain files or folders don't get uploaded to Git when I do a push. And I will just copy my usual. So I'll go through it real quick. .vs or .vs code directories are excluded. Anything that starts with bin as a directory is excluded. Any logs are excluded. So I'll be sure not to call anything that is real code any of these names. In terms of files, got a couple files here. These are sort of Visual Studio or Xcode project files. This one you get from Mac all the time. The solution files or make files. That's basically it. That's all there is to it. So I'll save that. That way when I push at the end of this video, I won't pull in anything that I don't want. You'll notice Premake will get pulled in even though it's an executable, and that's fine. I want to keep Premake along with the project here. So the way Premake works, and there will be other tutorials online, but I'll just go real quick over what I want Premake to do here for me. So I'll have a premake.lua file, and what this premake.lua file does is it tells Premake sort of what to do. So the first thing I want to do is define a workspace, and this is similar to what a solution would be in Visual Studio. So again, the first thing we want to do is generate a workspace. So we'll have a workspace, and I'll call it Hippo. Within the workspace, I want to define a start project, and this is a project we'll define later in the file. So start project will be Hippo editor, and that's what our project is going to be. Architecture will be x64, so we'll build in 64-bit. And I can provide configurations. So if you're familiar with debug versus release builds, that's basically what these are. So configurations, I'll have a debug and a release. Now I can define the project itself. So the project is called Hippo Editor. Location is what folder within our existing folder the code will live in. So again, I'll use Hippo Editor. I can define the kind of application it's going to be, and for us it's going to be a console app. The language, I can specify C++17. That's what C++. And then in the C++ dialect, I can give it C++17. Okay, now within this project, I have to define the kinds of files that I want included in the project. So I do that with this files. Now I'm saying that the files will be somewhere within this project's folder, and I can actually access this project's folder with a % open curly prj.name close curly, and I'll put all of my code under the source directory. And then within that directory, I want every .h file. Double stars means it'll do it recursively. I also want every .cpp file. One thing I do want to do for sure is define a flag, or compile flag. And the flag, I want fatal warnings. What this does is it treats every warning as an error, so it forces us to deal with warnings. And this is really useful when you're doing anything cross-platform, because what one compiler might think is a warning, another compiler might think it's treated as an error. So we really just want to catch anything as we write the code, so that we don't have to do a bunch of cleanup after the fact or whenever we switch operating systems. This should be all we need. So if I save this premake.lua file, I now need a way to actually run Premake against this file so it can do its work. this is where our tool pipeline will come in. So I'll create a new folder. We'll call it tools. And within tools, we can start writing scripts. And the way I've done this in the past, and I think the way I'll do it now, is each sort of script is its own Python script. And then I have a master sort of script that I use to interface with the subscripts directly. So to start, maybe I'll create a quick script called version.py. And this one will be very straightforward. It's just going to give us a version of some sort. And this is really just to test our tool pipeline. So within here, maybe we'll just print hippo tools version something dot something. And maybe, I'm not sure that the version script is the one that should define the version we're on. That seems like something that might be done at a higher level, but for now this should be fine. Say major equals 0, minor equals 0. We're at version 0.0. So I'll save that out. Now we have that script. And just to verify that we can run that, just from this directory here, I'll open a PowerShell window, which will allow me to run that script with Python. So I have Python 3 installed. If you don't have that installed, just Google it, first hit, download Python. You can use Python 2 or Python 3. For us here, we're going to use Python 3. So I'll just do a Python 3 in the tools folder. We'll run version.py, and you can see it prints out hippo tools v0.0. So it's exactly what we want, except we don't want to have to define when, let's say we want something to generate our solution, we don't want to have to type python 3./tools/solution.py. We want something that knows where to look, and I can just give it a simple command. I basically want something that looks like maybe hippo space gen, and that should generate the solution. It's not going to work, that's fine. Maybe something less typey, CLI gen, and then CLI build, and even CLI run. That should run the game. So let's go ahead and create that interface here. I'll just do it in the root directory, since this is sort of our project directory. Our new file, we'll call it maybe CLI.py. And CLI.py is the file that will actually allow us to interact with anything in the tools folder. So really what I want, again, if I want to be able to say something like CLI build, or CLI run, or CLI gen, anything like this, I think what I want is the command that I pass in needs to have an associated Python script in the tools folder. That way, if I want to create a new tool, for example a gen tool, I would add gen.py, and then I should be able to just type CLI gen from that command line interface, and that should just do it. So because we have version, what I expect out of this is to be able to type CLI version, and that should run that Python script. And then eventually we'll add a generate and a build to generate and build our solutions. So in order to do that, I need to be able to take in arguments passed in from the command line in this Python script. And we can do that with something in sys. I think it's just sys.argv, so I want to import sys. And maybe, just thinking ahead, I want to be able to do something like CLI gen build run. So I should be able to string together commands like this, and it should just handle them one at a time as it goes. So it'll first generate, then it'll build, and then it'll run the output. So if I'm going to be able to iterate over an unknown number of arguments, I need to be able to parse them based on what sys tells me. Sys gives you a couple of different ways to know what's being passed in from the command line. It's really just argv actually. So argv is a list of these sort of strings. They're space separated, and so what argv at 0 will be, it'll be CLI. Argv at 1 will be gen. Argv at 2 will be build, and at 3 will be run. So argv being a list, I can call len of argv, and that'll tell me the number of commands that are being passed in. So let's do a quick for loop. For I in range. Actually, I can do one better. For command in argv, sys.argv. And for this, I'll just print command. should be able to just go ahead and type CLI, actually python3 ./CLI.py, and you can see it actually prints out ./CLI.py because this is argv at 0. So if I do CLI hello world, you'll see I get CLI hello world. So this is exactly what I want. I want to be able to parse what I'm getting from the user's command line, and I want to be able to do something with this hello. And really what we're going to do is we're just going to build a path to this version.py with this hello and try to find a file that matches. Obviously though, I want to skip the first one. So maybe I'll say for I in range starting at 1, going through len of 6.argv, and actually I have to change this a little bit. So now cmd equals sys.argv at I. And so what I did here is went from a for each loop to a for loop where I'm starting at 1, so I'm skipping over that CLI piece, and I'm iterating over this many things, or up until this many things, starting from 1. So if I run this again, I should actually exclude CLI py now, and it does. So CLI.py is gone. Hello world come in. So that's the command I want. So maybe between commands, I want to be able to easily sort of determine which command is doing at which given time. So let's just print maybe something like this, just to be able to easily differentiate while I'm looking at the output when it's doing what command. And then we'll say maybe just executing command. And so again, let's just test that real quick. So there we go. Bunch of lines executing hello, bunch of lines executing world. Perfect. So first I need to define what folder to look in, and that's tools. And I don't want to have to write tools everywhere, so in case I want to rename it, I'll just have it appear as maybe a tools directory equals tools. And I want to be able to build this path. So maybe I'll make that a quick function. Def, let's actually run the command from here. So we'll call it run command, and it'll take in the command to run, and I'll build everything and run it from here. In order to run external files, I need a little help here from subprocess. Subprocess is a way for Python to actually run processes external to this sort of file, and I'm going to be running the Python 3 subprocess each time for each command. So basically the exact same thing that I was doing here, where I was saying Python 3 /tools /version.py. This is basically, this line is what I want to generate and run from this run command method. Now I wonder, because I'm thinking about multiple operating systems here, I wonder if the /s work. And nice, so this actually does handle that for us, so that's good, because I don't know what backslashes will do on other operating systems, and I know Linux and Mac uses /s, so we'll build it with /s. So really what this is subprocess.call, and here I build the path that I want. And so we'll start with Python 3, and then I need the directory, so the tools directory / the command itself. And so this should be tools dir and the command that I'm passing in, and .py actually. So this should generate what I want, and if I do executing and then call a run command with the cmd that I'm executing, that actually should work. So let's see what that looks like. So to test this, I should be able to just type python 3 /CLI.py and pass in version. And you can see that it is working. I'm getting my version out, and so that's from this version.py script that's actually running this code, and this is what will actually end up triggering Premake to generate a solution for us. Now I don't like having to type python 3 /py.cli every time, or cli.py every time. So what I want to do is be able to basically just type CLI version, and that should just know what to do. Unfortunately with PowerShell it's not that straightforward. So I am going to lean on WSL, and what WSL is, it's basically a Ubuntu built into Windows 10. This also allows me to make sure that it works on some form of shell or bash that will actually be somewhat similar to what I'm seeing on Mac OS or Linux. So you can actually see that I've got it installed down here already. If you haven't seen that before, I'll post a link here, but you basically want to follow Windows's guidelines here. So in order to have something like this that actually works for our tool set, what I'm going to do is create a bat file, call it cli.bat, and basically what I want this to do is to open up this WSL prompt at this directory so I can start typing in my commands. And the way I'll do that is like this, and this is basically just saying, hey PowerShell, open yourself up and run bash.exe at this directory. And bash.exe is WSL, it's what you're looking at down here. So now I've got the cli.bat, and if I open it, you'll see that I've got this open up here. Now you'll notice some things at the top here that you won't get this. This is something that I've done locally. Again, I've made changes to my WSL instance, and that's sort of the Ubuntu. Think of it like as an embedded operating system within Windows. So you can see I've made some changes, and I'll go through what those are now. Basically, the way we want to run this is, again, I want to be able to type CLI version, not Verizon, version. Again, you'll get a different error prompt here, but the point is CLI isn't a thing yet. We need to define what CLI is. So we do that in 2 steps. The first step is to create an actual shell script. So again, in my project folder here, I'll create a cli.sh, and this is the shell script that will actually be run by Ubuntu, in Windows, by Linux, or by Mac OS. And this is where we're actually going to tell it what to do. And it's going to go run Python 3, run the cli.py script, and pass in the arguments. And this is how you pass in arguments here in shell. So I'm saying use Python 3 to run this script and pass in all the arguments that I received just right through to Python. I should actually now be able to type cli.sh, and actually I might have to do cli.sh like this. And you can see it's running cli.py. I didn't give it any arguments, so nothing happened. So if I give it version, we actually get an error here. So you can see it's running our cli.python script, trying to execute version, and it can't. And it dies here with a file not found error. Python 3 tool/version.py. It doesn't know what that is. And probably similarly to the problem we had here with cli.sh, I might have to give it that / like we talked about earlier. So if we go to cli.py, all I really have to do is do / before. Again, I've just saved it. And now if I try this again, same problem. So might have to go one step further. The dot represents the current directory. It's possible that for some reason it's not running it from this directory, and it's running it from somewhere else. In that case, we'd have to give it the full path. It actually might even be that it just can't handle sort of local directories, it needs the full path. So it's fine, we can do that with OS. So let's import OS, and we'll replace the dot with something else here. I think it's os.curdir, yeah, curdir. I think that's it. And I don't know if that's a function or not. No, it looks like it's a string. So os.curdir should give us the current directory, and if we try that now, that's not right either. This might just represent the dot. Actually, I think it's get cwd, get current working directory, and that's a function. Returns a Unicode string representing the current working directory. And actually, I've got this wrong here. The way subprocess.call works is it actually expects a list of strings, like this, where the first one is the executable, what we actually want to run, and any string after that that is concatenated will be an argument passed in. So this way, we're going to do a subprocess call for every command that we run, and we'll do Python 3 with this as the argument. And this should actually work. So we'll do Python 3 /cli.py, and we'll pass in version. And you can see that we actually get something functioning here. So now I want to replace this piece, right? And that's where that .shell script comes in. So we've done this, Python 3 CLI.py, and pass in forward the arguments, basically. Now we need to be able to run CLI.sh whenever I type CLI. In my case, it'll actually work because I've already done this for my own environment. But what you want to do is use nano or some other sort of text editor to modify the ~/.bash_aliases file. So it's tilde/ is your home directory, and then .bash_aliases is what you're going to want to do to update. This is what you want to update. And you can see I've done this before for various other projects, various other reasons. But really what you want to add, yours might be empty. Yours might just have this line in it. All you want is this, alias CLI equals /CLI.sh. So you can see what I'm doing is I'm basically saying to the interpreter of the CLI that every time I type CLI, I want you to actually just replace that with ./CLI.sh, because that's the shell script that we've written. And you can see once you've done that, you'll have to run a source. So you're gonna rerun basically the interpreter part that sort of understands that reads the aliases, that reads your environment files and whatnot. So you're gonna want to redo a source on that file, so it picks up the changes. And now that it has, I should be able to just type CLI version. And you can see that works because this ultimately gets replaced before any processing happens. This is going to get replaced with ./CLI.sh version. You can see that works. And the way we're going to make sure it works every time we open this WSL instance is we have to actually add it to the end of what's called a bashrc file. So if I get out of here, I'll go nano tilde.bashrc. And a lot of this will already be there, sort of filled in for you. It sort of sets up the way your CLI is going to work, and you'll see it near the bottom here. There'll be an alias definition section, and it'll actually suggest that you do something like this, .bash_aliases. What you can actually do here is add this piece of code. So if -f tilde/.bash_aliases, this is basically saying if a file exists with this name, then actually run it. And that's what this is doing, the dot and then tilde/.bash_aliases. It'll actually do the equivalent of what our source command did when we actually wanted it to take effect immediately. So the source command, if you run that, it'll take effect within that instance of your WSL prompt. But if you want it to be there at the start of every WSL prompt, just by opening the prompt, you should have all of your aliases. You'll need to add it to this bashrc file. You can see at the bottom I've also got a couple extra ones. I added these environment variables and the message of the day. That's all unnecessary and not required. The message of the day, I believe, just prints out that bash aliases. But ultimately, this is what you want. And that's what allows us to ensure that our aliases are active whenever we open up a new instance of our WSL. So now for the good stuff. I want to use this to generate our solution for our project. I want to be able to type CLI gen solution maybe, gensln. Let's do gensln here. As you can see right now, I don't have a good way to sort of say invalid command or anything like that. It'll just actually die saying it can't open this file because it doesn't exist. That's fine with me. Let's just create a new file here called gensln.py. And what gensln is going to do is it's basically just going to do that same thing, subprocess.call, and it's going to instead call Premake 5 with an additional parameter for us to tell it that we want it to generate a Visual Studio 2019 project. So again, very simple. Import subprocess, and all we have to do is do subprocess.call, and again, it's an array of strings as we've learned. So cmd.exe, it's just going to run a cmd. Premake is a .exe, but it takes command line arguments. So I'm going to run cmd so I can pass those things in. So with this, I'll give it /c so that it knows that I'm getting a command here. Premake 5, and the argument I'm passing in is VS 2019. So again, run command. This is the command I want you to run. It's command prompt /c premake 2 / here since we're on Windows. And actually, yes, this is required here because we're running cmd.exe, which is outside of bash. So run Premake 5 and give it VS 2019 as a command line argument. So I'll save that. And if we look back at our folder here, and I try this again, you can see executing gensln. Now there's no Premake script found. Premake 5.lua. So I've not named this correctly here. So let's try Premake 5.lua. And let's run that again. And you can see right there, it's actually done some work. Premake 5 has generated hippo.solution and hippoeditor.vcxproj. So you can see now I've got this hippo.solution here, and I should be able to double click this. And you can see we've got a solution generated here. You can see it's already set to x64 because we're targeting the 64-bit architecture. Our solution has a single project in it, Hippo Editor, and it's empty, which is fine. Now, because I told Premake that our files were going to be, our source files were going to be in a source directory within the Hippo Editor folder, I'll go in here and I'll just quickly create a folder called src, and within source, I'll create a new file called main.cpp. I'm not doing anything through Visual Studio, and I don't want to, right? I want to be able to run my gensln command again so that it regenerates the solution with this file taken into account. And you can see it's done. It's very quick. And now that when I come back, you'll say that the solution has been modified, so we'll reload it. And you can see now I've got my main.cpp here. And I actually like this to be in the show all files view so I can see the folders. And you can see I've got my main.cpp source, and there's a beautiful empty file. So there we go. We have a project all set up, correctly configured and everything with our premake 5.lua file. And we've got a tool pipeline that's sort of already built in a modular fashion, so we can start adding scripts like build scripts and run scripts, and simply type CLI, the script name, and we should be able to get those scripts going. So that'll be it for today. Next time we'll work on actually adding some code, adding a script to build the code, and maybe I'll also just do some verification on a macOS system to make sure that the scripts are working and to make sure that nothing there is incorrect. So until next time, thanks very much for watching.